This is 7.5 of algebra. So here's some terminology with roots. Sometimes we'll use them, sometimes we won't. You sometimes also call this the degree of the root. So our first couple problems here are pretty similar to ones we've done before. When we were looking at the way the book explained it, they said, this one here looked like 27 to the 1/3. And the book wanted you to say, okay, what number can I multiply 3 times? So a number times a number times a number and get 27. I also showed you this way with roots, so it's not too new. Something that I would add, though, is that it's a good idea to have a sheet that lists your powers. So 2 squared, 2 to the 3rd, 2 to the 4th, 2 to the 5th, that sort of thing, and a couple numbers. The one I have goes from 2 to 12, and it goes from squared to the 5th, and just doesn't go into the thousands, so it only has some listed for them. That's a really good way. They're hard to memorize. There's really not a big need for memorizing them, so it's good to have that as a cheat sheet. So either you can know these off the top of your head, use your calculator, or use your cheat sheet. So the 3rd root of 27 is 3. The 5th root of 32 is 2. Again, you can either type these in your calculator, know them off the top of your head, figure them out the way the book had explained before, or use a cheat sheet. The 3rd root of 64, that's 4. And the square root of 36 is 6. Okay, so we've looked at this before. The whole a to the 1 over n is equal to the nth root of a, right? Whenever we have an exponent, you can rewrite that as a root. So, for example, x to the 1/3, that's the same thing as the 3rd root of x. And also a to the m over n is equal to the nth root of a to the m, or you can rewrite it as the nth root of a and the whole thing to the m. Both of those work. Okay, so we're going to rewrite these in radical form. Radical just means that you're using the roots. So our first one here, a to the 5/6. The bottom number, so a to the 5/6, the bottom number is your root. The top number is your exponent. So this turns into the 6th root of a to the 5th. You could also write this as the 6th root of a to the 5th. Okay, and our question here in B, notice that the exponent is just on the x. So we're going to have the 5 in our answer. We're not changing anything about the 5. And then I'm going to change this so that this is the 3rd root of x. Okay, this last one gets a little bit trickier, okay? We got 54y to the 2/3. We can simplify, so instead of just leaving this, so we could just leave this right as the 3rd root of 54y squared, but we can actually get more specific than that and have some numbers outside. So what we're going to do is first I'd go on your cheat sheet, okay, and look under for the 3rd root and double check to see if 54 is there. And 54 isn't there. So then you got to look what numbers are there that are factors of 54. So 27 is on there, okay? 2 times 27 is 54. So I'm going to rewrite this. 27 times 2y. So the only thing I did is I changed what 54 looked like, right? 27 times 2 is still 54. It just looks a little different. Okay, and now I'm going to rewrite that 27 as a power with an exponent. So 3 to the 3rd is 27. I'm going to group my 2y over here. And now I'm going to distribute in my exponent, okay? Notice that I'm distributing that exponent into 2y as a grouped thing. It's just one thing, okay? I'm not going to put my exponent to the 2 and to the y, because in my final answer, I just want one root. So this turns into 3 to the 3rd times 2 over 3, and 2y to the 2 over 3. Okay, if I put this over 1, I get 3 squared, and I'm going to rewrite this as a root, so this is the 3rd root of 2y squared. The last thing I could do is I could simplify that 3 squared up front, make that a 9. 3rd root of 2y squared. And that would be my final answer. So it's a bit of a process. I would suggest that you rewind this and watch that over again. It's a good methodical way to do it. Okay, so now what we're going to do is we're going to take the roots and put them into exponential form. So write them with exponents. Okay, so this is going to turn into s to the something. Okay, remember the root goes on the bottom, so the 3 goes on the bottom, and the exponent goes on the top, so the 2 goes on the top. Okay, the 12 is outside, so the 12 is going to be outside in our answer. I've got x to the something, root goes on the bottom, exponent goes on the top, so it's x to the 4/3. Okay, I'm going to have 4y to the, if there's nothing written here, that is a 2, a square root, right? If you think the square root of 49, that's 7, right? You know that you're taking the square root, and that's when we use a 2. So this will be to the 5/2. And finally, this one's a little bit longer, okay? We're looking at the 4th root, and we can, since it's a big number, just in general, you should check that number. What we're going to do is we're going to split this up so that 256 has its own root, and so that a to the 8th has its own root. Okay? Because if you look on your cheat sheet, or if you know this in your head, or use your calculator, the 4th root of 256 is 4. So this turns into a 4 out front. And now I can rewrite this with an exponent. So this is a to the 8/4. We can simplify that one more time. That's 4a to the, right? Because 8 divided by 4 is 2. So this is just a squared. Okay, last thing is taking an equation with a root in it and plugging into it, okay? So I've got r equals 73.3 4th root of m to the 3rd. And so we're going to plug in 75, okay? So r equals 73.3 4th root, and I'm going to plug in 75 cubed. So on your calculator, the first thing that you should do is you should do 75 cubed. So 75 to the 3rd. So this is r equals 73.3 4th root of 421,875. Okay, and now I'm going to take the 4th root of that number. So r is equal to 73.3 times, it's about 25.5. And then finally I can do 23.3 times 25.5, and that gives me about 1,869, we'll round it to. And that's calories per day was what that equation was talking about. And there's your homework.